Hello drone lovers, welcome to my channel. My name is KM. Okay, from the start, how would you design a drone from scratch? How will you pick the parts? So I have a spreadsheet that you can see from here that is designed by myself of the 11 steps to choosing the parts for your drone. Okay, the first thing is you have to decide is what kind of battery do you need. How heavy do you think you want your drone to carry the battery? So I chose a 1550 6S battery. That was my aim to fly 6S. So that decision has to be made first. So first thing you have to choose, you go to the supplier on the AliExpress webpage or somewhere else, and you choose a 6S battery that is able to supply 1550. So this one here, 150 mAh at 120 C, so the highest C as possible. And you choose that battery first and you find out what the weight is, and then you enter the weight in the weight column here. The rest of it, you have to decide what kind of frame you need. For me, I would want a frame that has no props in view, so there's quite a limited choice. So I have two. I've narrowed down to two that fancies me, which is the iFlight DC5 and the GepRC Mk4HD5. So these two have not decided yet. So first you have to go and find out the weight of the entire drone, the frame itself, without the components, but of course with the TPU and all these. So for the iFlight DC5, the weight is 150.4, and for the GepRC, I'll find out that the weight is 121, including the 3D printed parts. So for GepRC, it's pretty light, it's like 30 grams lighter. Okay, but I put the heavier one in my calculation first. Okay, so over here I have the weight of the motors. So motors I have chosen, we have not chosen yet, so I have to put in roughly a motor weight of 34 grams per motor times 4. So I have 136 grams. And of course this camera VTX and VTX antenna, this is the DJI system that I have chosen. So this is the Air Unit that I have chosen, and the Air Unit, if you go to the specs, you can find the weight of the entire system, which includes the camera, the Air Unit and antennas, which is 55 grams. Okay, for the ESC and the flight controller, I have chosen a 60M one because I believe a 255 gram battery would definitely need a 60M ESC. So I went for the iFlight Succex-D. Okay, so this one, you can choose other brands as well. So, but just make sure that you know the weight and you know the current that is able to deliver. So based on this one, at least it had the F7, based on F7 controller, this one has quite a good feature, and this one, the flight controller itself interface to the Air Unit with a special connector. So it's not bad for this one. See, it has a 6-pin connector to the Air Unit, and of course the ESC itself is rated for 60 amps, burst current of 80 amps, which you may not need unless you're flying 7-inch and above. But I'm flying a 5-inch and I'm still using a 60 amp with a possibility of upgrading to 7-inch in future, who knows. So this is definitely suitable. So what I did was I found out the weight. So the weight for the ESC is 14.4, the weight of the flight controller is 7.5, so it comes up to be about 21, 22 grams. So I just add a bit more for the rubber grommets and the screws. So I come out to 30. As for the receiver, I'm choosing the R9 Slim. So R9 Slim itself, the weight is quite light based on this one. It has 2 antennas and the weight is 4.3 grams with antennas. Okay, so I put this weight in here as well. 4.3 grams with antenna, and I have a GPS. I'm using the Beitian GPS and a holder. So roughly about this weight for these two. And I have battery support and protector. Normally I use a credit card. One credit card is roughly about 5 grams to protect the battery, and I have a lot of foam and so forth. It's about 10 grams altogether. And I'm carrying a run cam or a GoPro with TPU mount, and that comes up to be about 100 grams. And the props itself, I'm using Gemfans 51466, which comes out to be about 16 grams, and other things like buzzer, landing pad, battery strap, I can add it here. So my total weight of my quad here now it stands at 794 grams, and I chose a 5-inch quad. Okay, and then on top of that, my desired thrust to weight ratio, I need to be at least 9. Okay. Typically is 8.5 to 9.5, so 9 is right in the middle. If you can get 9.5, I think your quad will fly much better. So with 9, with this weight, I need a total thrust of 7143, and I'm using 6-cell battery, and based on this weight, my formula calculates that I need a 2208. So 2208 is fine. I can search for 2208. And my motor kV is between 1700 and 1950. So I went around and shopped for a motor that can deliver a thrust of 1785 grams or close to that. So I decided to go for the 5146 because 51466 Gemfan blades are close to this spec here. So I went to check this thrust to see how much is it from various motors of that size. So if I were to look into particular motor, Zing. Okay, I have a spec here. Okay, so there's no okay, what I'm interested in is around 1700 kV. Okay, because I'm using my Nazgul, which is about 2750 kV on 4S, and if you multiply the kV by the voltage of a 4S battery, I get about 40,000 RPM, and for the same 40,000 RPM using a 6S, which is 22.2 volts, I would get around 1750 kV. So I look at motors around 1700 kV. So for 1700 kV, there is no 51466, but for 1800 kV, there is a 5146. So I look for the 100% thrust. 100% thrust, I have a load current of 40.6 amps and a pool of 1.749 grams. So I use these values and I put it into my spreadsheet. Okay, I have 1749 grams. Okay, and also I found out that motor that I'm planning to use is a T-Moto Pacer, and this one can deliver, but this one doesn't have the specs. That's the thing. So in order for me to choose that motor, I didn't choose the the iFlight one, I mean the Zing one, and I prefer the T-Moto one because it's one-piece bell. So for the T-Moto one, which has a one-piece bell, the specs are this. So they only have 1750 and 1950, so there's no 1800. So this is the weight, 36.9. So making use of the weight of this motor, 2208. Okay, let's look at it. This is a 2208. Where's the top page? This is a 2207. Sorry, this is not 2208. So 2208 is heavier than this. Okay. So it's 2208, 1750 kV. Okay, so you have this one, or this one, yeah, 2208. So based on 2208, the weight should be 39 grams. So it's much heavier. So I make use of the weight here to enter into the spreadsheet of 39 grams. So it's 39.2 grams. Okay, and the total weight of 4 motors is 156.8. Now the motor current, as I saw just now, was 40.63, so I enter it here as well. So the thrust now is, for this weight of the quad, for these motors is 6996 grams, and I'm getting an 8.8 thrust to weight ratio, which is still in the rate because I need a thrust of 9, around 9. So I have to reduce weight somehow. So, but I try to complete this first. Now I determine what C rating my battery has. So based on my Tattu battery, okay, based on the Tattu battery, this battery itself is 120C. Okay, so I enter 120C, and according to the calculation, in order to attain the maximum current here, I would need a battery of 1300 mAh or maybe 1400 mAh. So 1400, I enter 1400, I have less than 120C. So I decided to go for the 1400 mAh, which is the middle one. And the weight of the battery is 226. Okay, so 226 is the weight of the battery here. Okay, I entered it here, and now I have to look back again to re-enter the information here on the top. So 226, if I go down and look at my thrust, yes, with that weight I'm able to achieve the thrust to weight ratio that I want to for this quad. Okay, but at the end of the day, I decided to go for a lighter frame. So I went for the GepRC's frame, which is 121 grams, including the 3D printed parts. Okay, including the DJI FPV TPU as well. Okay, so I entered 121 grams here in the spreadsheet now. So instead of 150, I entered 121. You can change it, and now my weight of the quad is 735. Okay, so with the weight of 735 with a 5146 propeller, I have a thrust of 9.5. So I get the high side of the range of the typical value, which means I'm able to choose a lower pitch prop as well, and it will still work, it will still fly well. So this is a good design. So I decided to stick with this one, and I don't have any problem with excessive current drawn. Yep. So with this, these are the parts that I have chosen. And maybe there's some plus minus weight here. I'm not sure. If I carry a GoPro, maybe I need 130 grams, including TPU. So I would come up to 765 and I will still have a power or thrust to weight ratio of 9.14, even if I'm carrying a GoPro. Or maybe if a Hero 8, which is much heavier, I'm still having a thrust of or weight to weight ratio of 9, so it's still okay. So you can play around with these figures and I can still see that my weight is okay. Oh yeah, that's another thing I forgot, because just now I have motors, right? So I have to put in 39.2 here for the motors. 39.2 times 4 is 156.8. So the total weight of my quad now with a GepRC is now 796, which brings my thrust load down again because of my GoPro. So if I decided to use a lighter GoPro or lighter camera, I may be able to meet the weight that I want. But anyway, for a typical thrust to weight ratio of 8.5 is still okay. And don't forget, I can play around with different props. So if I use a heavier prop at 5055, okay, if I look at the specs of the motor of zinc, okay, there is for the 1800 I can use 5055 as well, and this one is 1903 4157. So if let's say I use this motor, will it burn my ESC? So I just key in this value here, 1903 4157. So 1903, and then for the current is 51 or 41. Let me see. For the current is 4157. Okay, so for the current is not much different, 41.57. Okay, and I just checked through. With this, I have a thrust of 9.8. I can carry a GoPro up to 140 grams, and I still have a thrust of 9.5, which is at the high side. And my current drawn with 41 is still below 1400 milliamp hours, so I can still make use of my current cell capacity of 1400. But don't forget, 1400, even this rig at 120 C, for burst current it can go double the rate. But I'm not going to stress my battery because I want my battery not to have any voltage sag, so I try to maintain everything within specs. So that's it. This is how I calculate the parts, and this is how I choose the parts for my drone in 11 steps. Okay, let's do a simple test on the battery. I will just do a quick one, just to make sure that the voltage is not anything wrong with it. Okay, let's cut it off first. Four, 5. Okay, let's try doing one by one. This would be a 6S. Let's look at it. It's a R-Line Tattu 1400 120C version 3 R-Line Tattu. Okay, let's look at it. Alright, 3.8 volts, only 1 or 2 voltage is 3.79, pretty good. Next package would be this would be the Beitian, I believe. Yes, this is the GPS module. Okay, next one would be the flight controller. I think so. Yes, this is from Banggood. And this would be the Succex flight controller with, oh, they even give you this. Great. This is the antenna mount for the I think it's GepRC. Hopefully Alright, the last one will be the GepRC Mk4 frame. Okay, so the last one. Let's give it a cut. Alright, so in this GepRC frame, you have the instructions, the stickers, battery straps, 2 of them, some landing pads, some battery pads, a bunch of screws and the standoffs. Oh, there is another one here. Okay, so I have 2 of these already, identical. And then I have another battery strap, 3 battery straps, the feet, the arms, the camera, protect side wall, some cable ties, the top and bottom plate, and some tools. Well, hopefully this is complete, and I'm waiting for the rest of the parts to come in before the assembling can start. So there it is, all the items, or partially all the items. Okay, we still have to wait for a couple more. The motors, the feet, motor protector, the receiver, and what? And the one more, I can't remember what is it. Oh, okay. Well, almost there. Alright, we'll wait for it. We'll wait for the next ones to come, then I'll do another opening. Finally, all the parts that I have bought that I'm going to use to build the new FPV HD FPV drone is here. I still short of one item, which is the FrSky Slim Plus, but I plan to use the RSSR in it as well. So I have 2 choices. Depending on what I set, I can set the UART channel to receive from either the RSSR or the Slim Plus. So since the Slim Plus is not here yet, I will start my build first with the RSSR. Okay, let me get to work and I will show it to you. Okay, let me introduce you the parts that I got. This is the GepRC Mk4 HD5 frame. I also got the protector for the arms, and this is the HD version where you have the TPU mount for the FPV Air Unit. And I'm going to use a 1000 microfarad 50 volt capacitor instead of the one that is provided by the ESC. And over here I have the T-Moto Pacer. This motor is a 2208 motor, and it's 1750 kV for 6S. Okay, so the motor is this. Okay, looks nice. And here is the flight controller. This is the Succex-D TwinG F7 flight controller and its corresponding 60 amps ESC. Okay, this is the ESC. This is the capacitor that I won't be using, and this is the flight controller. Seems like the cable to connect to the DJI is provided as well. And then over here I have the RSSR receiver. This is a used one. Basically I need to flash this with the F-port flex firmware, and I'm going to use F-port with 1 wire. And this is the RSSR antenna that I bought new. this is of course the FPV Air Unit from DJI, and this will be my iFlight props. This is 5146. Okay, for Nazgul. Okay, so that's it. I'll get to work and I will show it to you when it's almost done or when it's partially done.